Welcome in Sri School of Mathematics. Today I will discuss subgroup. Subgroup, a non-empty subset H. H is the subset of G. Non-empty subset said be the subgroup of G if H itself a group, means that S satisfies all properties of the group under the same binary composition as that of G. Then H is called the subgroup of G. Equivalence relation on group is the similar way that equivalence relation on set. Equivalence relation, uh, right congruence modulo H and left congruence modulo H. In this section, if G is a group and H is the subgroup of G, then the relation right congruence modulo H is the equivalence relation on G. Further, for any A belongs to G, the set HA where H belongs to the H belongs to the subgroup H, small h, in the equivalence class to which A belongs. Similarly, in the left congruence modulo H, H belongs to the H is the equivalence relation to which A belongs. Important remarks of the subgroup. First is the non-empty subset H of group G is the subgroup of G if and only if AB belongs to the H, AB inverse belongs to that, means that AB inverse belongs to H, then H is the subgroup of G. H is the subset, then subset H is the subgroup of G. Similarly, next important property, let G be the group and H be the finite non-empty subset of G, then H is the subgroup of G if and only if AB belongs to the H. For all AB belongs to H. Some important result on the subgroup. If H and K are the two subgroup of G, then HK is the subgroup of G if and only if HK and KH. For any two subgroup H and K of a group G, H intersection K is the subgroup of G. Next result, Lagrange's theorem. The order of any subgroup of a finite group divides the order of the group. Most important theorem of the group, Lagrange's theorem say that the order of any subgroup, the order of the group and subgroup is the number of elements in this group. Finite group divide the order of group. Similarly, fourth property is the if H and K are the finite subgroup of group G, then order of H K equal to order of H, order of K upon divided by order of H intersection K. Similar property discussed in previous lecture. Center of group is also the subgroup of G.